All right. Here we go, everybody. We're going to have some fun today. We're going to learn how to solve a radical equation. I know what you're thinking. How cool is it? Because it's radical. Cal. I think one of you smiled at that. Oh, is that a hand raise because someone is excited? They're smiling because they laughed at my joke. All right, so a radical equation, pretty straightforward. It's an equation with a radical in it. Specifically, though, the radical is over the exponent, right? So our variable, whatever we're trying to solve for, is underneath one of those radical symbols. It could be a square root, it could be a fifth root, it could be a 200th root. Probably not that high, but you get the idea. And we're just going to solve these equations, right? Just like we've been doing all year. We're solving problems, we're learning problem-solving process. And so we want to be able to essentially get the variable, the x in this case, all by itself on one side of the equal sign. So I've got a little radical equation down here, and I've got the square root of x plus 6 equals 5. Now, right now, this radical symbol here, you can think of it as it's like a parenthesis in a way. It's trapping the x and the 6. So I wouldn't be allowed to just subtract 6 right away. I can't do that because that 6 is underneath that root, that radical sign. So before I do anything else, I have to get rid of that radical. I have to cancel it out. Now, first off, what type of a root is that? A normal one, a square root, right? If there's no index, if there's no number up here, we assume it's a square root, okay? So that's a square root, and I want to cancel it out. So whenever we cancel things out in algebra, we always just perform the opposite operation, right? If I had a plus 6, I would subtract 6. Well, if I'm taking the square root of a number, what would be the opposite operation? Squaring, right? Raising it to like the second power. Aren't squaring and square roots opposite operations? Like 5 squared is 25, and the square root of 25 is 5. They cancel each other out. So if I want to cancel out that radical, I'm just going to raise this entire left side of the equation to the second power. But to keep it balanced, what else do we have to do?
Do it to the right.
Yeah, the right side has to also be raised to the second power. And so on the left side, we've got the square root of something squared. Well, all that happens here is like the square root and the square cancel each other out because they're opposite operations. It's like adding 2 and subtracting 2. You're right back to where you started. So we just write x plus 6 equals. Then on the right side, we can actually perform that calculation. And everybody, what is 5 squared? 25. Nailed it. Now at this point, I'm pretty sure you can all solve it, right? What's our final step here? So subtract the 6 from both sides. Exactly. You got it. And again, it's that opposite operation, right? We're canceling things out. That's a plus 6. I'm going to subtract 6 because that would equal a 0, so it's gone. But over on the right side, 25 minus 6 equals 19. So we say, hey, x equals 19. What do you think? Is that pretty straightforward so far? All right, that's the only key step. It's undoing a root just by raising it to whatever that exponent is, whatever the index was. Is how it pretty much works. I will let you know ahead of time. Spoiler alert. Sometimes we get those extraneous solutions. Does anybody remember what an extraneous solution was? You're trying to forget them. Those are sometimes in your answers that you get. If you plug it back into the problem, it doesn't work. But real quick, you probably do this in your head. If I plugged a 19 back in for x, would the left side equal a 5? Yeah. Real quick, if you make this 19 and you add 6, you get 25, and then is the square root of 25 5? Does that work? It does, right? You don't have to actually do a lot of work, just kind of visualizing it. You could probably do that pretty much in your head. So yeah, this is good. 19 is definitely the solution to this equation. Pretty cool? Now, the only thing you have to kind of be careful of is which type of a root are we canceling out? That first problem, we squared both sides because it was a square root. That works. This right here is what type of a root, though? A cube root. Yeah, there's a 3 that's an index of 3. And so pretty straightforward still. How am I going to cancel out a cube root? What do you think we do to both sides of the equation? You cube it. Exactly. So all we're going to do is raise both sides to the third power. So this whole thing on the left gets raised to the third power. Everything on the right side gets raised to the third power as well. Now on the left side, the cube root and the cube, well, those just cancel each other out because they're opposite operations. They're gone. We're now left with 2x plus 1 equals, anyone know what 3 to the third power is? 27, good. Remember that an exponent doesn't mean like 3 times 3. You're multiplying 3 times 3 times 3 again, which does give you 27. Awesome. All right, go ahead and finish that problem real quick. Get that x by itself. Subtract the 1. Get 26. Divide by 2. And what does x equal, everybody? 3? A 3 with a 1 in front of it. Yeah, 13. Anybody else get 13? Excellent. Excellent. Good to see. Oh, hand raised. They did it too. Okay. Any questions yet? Hopefully not too insanely difficult. It's not like I'm making up some imaginary numbers or anything like that, right? Oh man, that was a doozy. Yeah, when are we going to add imaginary moving on. All right, try this one on your own, everybody. Yeah, it looks insane, but it's actually super simple. Because how do I cancel out one of those roots? And remember, what you do to one side, you do to the other side, and look what happens. Let's go ahead. I'll give you about a minute. I want you to work this through and solve for x. And let's see what you get. All right, it looks like most students have got an answer for x. Let's go ahead and check those steps just to make sure that we're good. So first off, you check out the index of these roots. All right, and on the left side, I see, hey, there's a 5 there. It's a fifth root. Well, the opposite of a fifth root would simply be raising it to the fifth power. So I'm going to raise this entire thing to the fifth so that it cancels out. But just like any equation, if I raise the left side to the fifth power, I have to raise the right side to the fifth power. And that's actually not that big of a deal because there's a fifth root on the right side as well, which makes this really nice and easy because then on the left side, the fifth root of something to the fifth cancels out. And on the right side, we're going to have the exact same thing happen, right? The fifth root cancels out with the fifth power. And we're left with a pretty straightforward, like algebra 1 problem. And here we're just going to solve for x. So I can subtract 2x from both sides to get a 4x over here. I can subtract 4 from both sides to get a negative 20 over there. Then just divide by 4. And did anybody get x equal to negative 5? Yeah? A couple of you? Anyone at home? There. Oh, 2 people. Fancy. Cool. All right, questions on any of these steps yet? or about the concept of raising to a power to cancel out the root? Then moving on. So sometimes, though, you're not going to have the radical by itself just yet. And so we do see that's a fourth root. But see how there's some other numbers out in front? Like there's a 7 there and a 2 there. Since those aren't part of the radical, our first step, just like any time we've got like a parenthesis or an absolute value, if you remember earlier on in the year, our first goal is to isolate or get by itself that radical. So go ahead and write this problem down real quick. And then I want to work through it with you together because I don't want you to make a very simple mistake in the very, very first step. Most students, when they see this, 7 plus 2, fourth root, what do you think most students want to do with this 7 and the 2? You kind of want to add it right away. It looks like, oh, I know 7 plus 2 is 9. You're like, oh, I got it. But that is not correct. Okay, we can't do that. Because if you think about the order of operations, this is being multiplied and this is being added. And PEMDAS says, hey, multiplication has to come first, meaning I have to figure out what like this whole term equals first before I add in the 7. So if I added the 7 and the 2 first, I would be violating the order of operations. So we cannot do that. And what we want to do is cancel each of those numbers out separately. Cancel them out one at a time. Don't combine them. So now, am I going to cancel out the 7 first or the 2 first? The 7. Excellent. Good. Yeah, so when we're canceling things out, you always get rid of whatever's being added or subtracted first. If you remember, PEMDAS backwards is SADMEP. So subtraction and addition, cancel out first. This is a positive 7. So to cancel it out, I'm going to subtract 7. And we do that from both sides. Which leaves us with 2 times the fourth root of x minus 6 equals, and on the right side we can take 13 minus 7, and we get 6. All right, is the radical all by itself yet? Can I raise it to the fourth power at this point? Now we're going to do one more thing, right? What do we still want to get rid of? That 2 in front. How do I cancel out this 2? Should I subtract it from both sides? Nah, it's being multiplied with that root. The opposite of multiplying, that's dividing. So we're going to divide by 2. Divide by 2 on both sides, right? So those 2's cancel out, which is great. That's what I want. I'm left with the fourth root of x minus 6 equals 3. Okay, at this point, now do we have the root isolated on one side of the equal sign? Yeah, we do have that now. We can finally cancel it out. And hey, how am I going to cancel out a fourth root? Go to the fourth power, right? We're going to raise both sides to the fourth, right? That whole left side gets raised to the fourth power. That whole right side gets raised to the fourth power. So on the left, the fourth root of something to the fourth will just equal that radicand, the stuff underneath that root symbol. 3 to the fourth power. That might be kind of tricky in your head. What I would do is separate it into 3 squared times 3 squared. What's that equal? 81, right? 9 times 9. You all know that. So that's a nice way to think of 3 to the fourth. It's 3 squared times another 3 squared, and you all know that's 81. Final step, well, cancel out a negative 6 by adding 6. X equals, anybody else get 87? Yep, yeah. Oh, yes. Okay, I like that hand raising. It's convenient. Questions on any of these steps at this point? If anyone at home has a question, feel free to raise your hand. No hand raises. Okay. Everyone here, we're good to go? Hopefully it's not too insanely crazy so far. Main thing I want you to be aware of is do not add those up in the first step. I know it's tempting because like you know the answer off the top of your head really, really well, but got to cancel things out.
Actually, like you first were like, oh, what does it look like you want to do add the two? I'm like, oh, I actually knew already.
Oh, that's perfect. Like you've already trained your brain to know, hey, you don't combine them. You cancel out one thing, then the other term. That's fantastic. Great. Good to hear. All right. I want you all to try this one on your own right now. So it's the square root of 5x, all being divided by 2, then minus 8, and that's equal to a negative 3. Just go ahead, take a minute, and work through this problem, and you're just going to start canceling things out one at a time until you get that root all by itself on one side. Then you're going to cancel it out with that new technique I showed you at the beginning of class. All right. Looks pretty good for most students. Only issues I saw were some confusion as to which term do we cancel out. Do I get rid of the 2 first or that negative 8 first? And so just the one rule of thumb I want you to always remember is to always cancel out whatever's being added or subtracted first. Okay, you always get rid of addition and subtraction first. So this 2 is division, so you don't get rid of that first. Instead, we're going to cancel out this negative 8 by adding 8. If you don't do it in this order, you will get a different answer. So just try to keep in your mind add and subtract. Always look for the add and subtract first. Get rid of those things until you have a single term, a monomial. Then start working on getting rid of like multiplying and dividing. So at this point, we then have the square root of 5x divided by 2 equals 5, because negative 3 plus 8 is 5. Here, I want to get rid of this 2 on the bottom, and we're currently dividing by 2, right? That's what that fraction bar means. It means division. And the opposite of dividing by 2 would be multiplying by 2, right? Something times 2 and something divided by 2 would just cancel out. But if I multiply the left side by 2, I have to multiply the right side by 2. We cross those out, because that equals 1. Now I have the square root of 5x equals, well, 5 times 2 is just 10. And we finally have that root all by itself, right? And this is the new skill that I'm showing you today, how to cancel out a root to solve an equation with the root. And that's a square root. So the opposite of a square root is squaring something. So we're just going to raise both sides to the second power. And when we do that, well, the square root of something squared is just that something, or in this case, it's just the 5x. And that radical is gone out of our equation. On the right side, 10 times 10 is 100. Last step to get x by itself is just to cancel out that 5. And since that 5 is being multiplied, we just divide both sides by 5, and see that x equals 20. Anybody here get a 20? Boom. All right. Anyone at home get 20? Yes. All right. Oh, wow. Oh, my goodness. That's delightful. Well done, class. Oh, my, they're still coming in. What? Carlos, that's just you over and over again. All right, now here's the part that you don't like. Checking your answer. And we haven't been doing that, but sometimes we get something that's known as an extraneous solution. And what's going to happen here is we're going to solve this problem. We're going to get an answer, and all of our algebra is going to be good. It's going to be correct. It's going to be like, wait, I did every step the right way. I know I did my math right. And you get a number, x equals this. But when we plug it back in, it's not really going to work out. So that's what's known as an extraneous solution. It's a number that we get for the variable. But when I plug that back into the original problem, it does not make that equation true. You might think, wait, did I make a mistake somewhere? And well, no, you didn't. This is just what's known as an extraneous solution. Now, if you remember, in the absolute value equations, that's the first time this year we had these extraneous solutions. And there was a step in the problem-solving process where we could look at that problem and be like, wait a minute, that's an impossible equation right there. There can't be a solution. So there is going to be a step here where we might be able to realize, oh, wait a minute, that can never happen. And you can tell before you even finish solving the problem that it's going to be extraneous. Let's see if we can spot it. So go ahead and write this problem down. 8 plus the square root of x plus 1 equals 2. What would be the first step? Subtract the 8. Exactly. Get rid of what's being added or subtracted. We're isolating that radical. So yeah, subtract 8. I totally agree. And we've got the square root of x plus 1 equals 2 minus 8. That's a negative 6. All right? What should we do next? Oh, I heard squaring, but also I heard someone say, wait, we should stop. What do you mean? Why should we stop right here? Check it out. The square root of something equals a negative 6. If you take the square root of a number, any number at all, can you get a negative? No. Square roots are always what type of a number? Positive. Every time. A square root will always turn a positive. So there's no number in the world that I could plug in for x that if I added 1 and I took the square root, that answer could be a negative 6. It is impossible. It's not going to happen. All right? So if you ever get to this point where you're taking a square root, or for that matter, any even index root, a 4th root, a 6th root, it can't equal a negative. Okay? What about an odd root? Do you think like a cube root could ever equal a negative? Yeah, this is actually weird. So sidebar real quick. If I had negative 2 to the third power, go ahead and multiply it. What's negative 2 times negative 2 times a third negative 2? Yeah, isn't that a negative number? It's a negative number. So if I took the cube root of a negative 8, could that work? Can you take a cube root of a negative number? Yeah, we actually can. It equals a negative 2. All right, so that's kind of strange, but hey, it happens. If the index is an odd number, you can get a negative. It's only when your index is an even number, such as this case, when it's a square root, that you're never going to get a negative, okay? So just for fun, let's keep on playing this out and see, well, what would happen if I continue to solve this? And I'll just work through this. You can just watch if you'd like. So I'm going to square both sides. Remember, this is a negative 6. But when I square both sides, we get x plus 1 equals 36. Subtract 1, and we get x equals 35. And you'd think, hey, that's my answer. It looks like x should be 35. And all the math is good, right? It checks out. We did every step correctly. But if we go back to the original problem, if I plugged in a 35 right there for x, I get 35 plus 1, which is 36. So we have the square root of 36. And we all know, what is the square root of 36? It's 6. So this whole thing becomes a 6. All right? So now, what's 8 plus 6? Is it a 2? 8 plus 6, is that 2? No, it's not. Doesn't work, right? And the whole reason is from this step right here, where you have a square root equaling a negative number. That's an impossible scenario. That can never happen. So we can stop and say, nope, it's impossible. There's no solution. So we just use our good old symbol, that circle with a slash through it, slash, that indicates, hey, there's no solution to this equation. There's no number we could plug in for x that would make this equation true. Cool, so just be on the lookout for that. I'm probably going to try to trick you, but I'm telling you ahead of time, so it's not like it's a trick question, right? If you know that it's coming. I'm pretty sure that's how that works. Any other questions on extraneous solutions before we move on? All right. Let's keep rolling. Oh, man. Look at this one. What is that? Is that a fraction for an exponent? Golly, I've never seen that before. Wait a minute. Didn't we just have a test on that? Oof. Yeah, the rational exponents was a struggle on that test, for sure. So we're going to retest on that in a couple weeks. Don't worry. You'll get a chance to relearn it, to repractice it, to brush up on that skill. Now, the basic thing with these rational or fraction exponents is you simply take that fraction and you leave the numerator where it is. But the denominator is what's going to move. We take that denominator and we move it in front of that whole term and we make it the index of that root. All right, so something to the 1/4 is the same as the 4th root of that base. So we could rewrite this as just the 4th root of 2t plus 1 raised to the first power, right? Because that's the numerator, but I don't really need the 1 there because anything to the first power is just itself. It doesn't really change it. And then I've got this minus 1 equals 2. That's just the rest of the problem. All right, so basically from this point, if you ever see a fraction for an exponent, just rewrite it as a radical, and then you can solve it just like we've been doing all these other problems. Cool? All right, from this point, I want you to go ahead and solve this the rest of the way on your own. Again, take about a minute. All right, now once you get that answer, what do you think you need to do? Oh, plug it in. Did I give you an extraneous solution right off the bat? What? Does that sound like something I would do? Maybe. Well, let's go through the solution. See what you got. First off, this radical, this fourth root, is not by itself on the left side. There's a -1 after it. We have to cancel that -1 by simply adding 1 to both sides so that we get just the fourth root of 2t plus 1 equals 3. Now looking right here, does that seem like that could be a possible answer? Could a fourth root equal a positive 3? Yeah, an even root could equal a positive number. That's fine. It's only when those even roots equal negative numbers that we get into trouble. Now to cancel out a fourth root, we raise it to the fourth power. And we do that on both sides. On the left side, the fourth root to the fourth cancels out, and we're left with 2t plus 1 equals, do you remember what 3 to the fourth is? It's 81. Yeah, it's like 3 squared times 3 squared, or 9 times 9, which you all know. Here, pretty straightforward algebra problem, right? We're going to subtract 1 from both sides so that 2t equals 80. And then just divide both sides by 2. And what does t equal, everybody? 40. Nice. Anybody else get 40? Yeah. Super good. Anyone at home get 40? All right, all right. And does it work if you plug it back into the original problem? Sure. Yep. 2 times 40 is 80, plus 1 is 81, and the fourth root of 81 is 3. 3 minus 1 equals 2. All checks out. Okay, I've got one more problem for you. Yeah, and we're done. But I need to warn you ahead of time. You're probably going to want a fresh sheet of paper for this. Like a whole page. Just in case. Come on, look, we have like an hour left. I'm not going to take an hour for one problem, but just, it's a lighter lesson today. All right, so don't get too crazy upset. But just be prepared. Okay, are we ready? Shake it out. All right, make sure your neck is nice and loose. Make sure you can, touch your toes. All right, here we go. Example number 5. So I've got a little note at the top, and that's going to be important here. So go ahead and write down the example. Don't worry about writing that remember up top. I'm going to bring that up in a moment. But here's the problem. It's the square root of 4x plus 1 equals 3 plus the square root of 4x minus 2. So the 3 is right here, right? It's separate from this radical. It's its own term. There are 2 terms on the right side, right? That's technically a binomial, the 3 and the root. Now, on the left side, we have a radical by itself already, don't we? Like in this left side, that's good to go. How would I cancel out that square root? Just by squaring it. Nice and easy, just like we've always done. And that is the correct thing to do. I'm going to square this right here. But here's where my little note's going to come into play. Because if I square the left side, I also have to square the right side. But look at how I'm writing this. You can only square an entire side of an equation at once. I can't square the individual terms because on the right side, that's now a binomial. There are 2 terms. There's the 3 and there's a square root. Okay, so now look up above at my little note there that I said, hey, remember this? 3 plus x squared does not mean 3 squared plus x squared. You cannot do that. 3 plus x squared means you take a 3 plus x and you multiply it by another 3 plus x, and you have to distribute both of those terms all the way, right? And you're actually doing 4 different products. Same thing's going to happen in this example 5 on the right side. Now on the left side, that's nice and easy. What happens here with the square root and the squaring? What's going to happen with those two things? Those are great. Radical, square, gun. And the left side is definitely just a 4x plus 1. That's great. But the right side, we cannot just write 3 squared plus 4x minus 2. Because I'm squaring that entire side. I'm squaring the 3 plus root 4x minus 2 times a second 3 plus the square root of 4x minus 2. Isn't that what squaring means? You're taking that term, that polynomial, you're multiplying it by itself a second time. So there's a little more work we're going to have to do here, right? But that's the key concept. I can't just distribute that 2 to each of those terms. And even though I'm bringing this to your attention right now, and I've given you a lot of ample warning and everything, I know that some of you are still going to forget this on the test, and you're just going to square both of those terms, and it's not going to work out for you. Now, we do have to do a little bit of multiplying here. I just want to let you know ahead of time, it's a slightly longer problem, but it's not difficult. Okay, it's actually going to work out pretty nicely. So our left side stays the same for now, right? 4x plus 1. But let's go ahead and multiply these two binomials together. Now you might use that process known as FOIL that you've heard in earlier years. I like to think of it as taking one term, like this 3. I'm going to distribute it to each term in that second set of parentheses. So first off, everybody, what is 3 times 3? 9. Okay, was that difficult? No. All right, this is not a difficult problem, trust me. Now take the 3 and multiply it by the square root of 4x minus 2. What's that going to equal? Yeah, you just put a 3 in front of it. It's 3 square root of 4x minus 2. Right? They're unlike terms. They don't get multiplied together. They just kind of hang out next to each other. Okay, now be honest. Isn't that kind of easy also? I think that's a very easy multiplication step right there. Okay, moving on. So I distributed the 3. Now I had to distribute this second term, this square root of 4x minus 2. So let's distribute that times the 3. Well, guess what that equals? 3 times the square root of 4x minus 2. That's the exact same thing we got before. It's 3 times the square root is simply 3 square root. Well, the square root times 3 is still 3 square root. Now this last one's actually kind of nice. The square root times the exact same square root. Remember what happens if you take like the square root of 3 times another square root of 3? What does that end up equaling at the end? Just a 3. Don't the roots just cancel out? That just equals a 3. So we can do the same thing here. The square root of 4x minus 2 times another square root of 4x minus 2 is just going to equal what? Nice, that's exactly right. Just a 4x minus 2. Basically, the radicals cancel out. So plus 4x minus 2. Because that's this root times that root. So it'd be that root squared. So you have a square root of something squared. Those cancel out. You're left with the radicand, the stuff underneath the root. All right. That was the trickiest step, I guess you can say. But if you look at each one of those products individually, weren't they pretty simple multiplication steps? The only thing we had to actually think of was what 3 times 3 was. And you all got that. Now, are there any like terms on the right side that we could combine? Yeah, we do have a few things. So first, let's rewrite the left side, the 4x plus 1 equals. Okay, so I've got a 9 here. Do I have any other constants, any other numbers all by themselves? Yeah, we at the end is a negative 2. What is 9 minus 2? 7. It took us a little longer than I was hoping. 7. All right, next we've got 3 square root of 4x minus 2. Do I have any other square root of 4x minus 2s? Yeah, I'm going to add 3 more of them. So how many of those square roots do we have altogether? 6 of them, right? If I have 3 roots and I add 3 more roots, we have a total of 6 roots. Now the roots are still the same. The square root of 4x minus 2, they don't change. And the last thing we have is this plus 4x. Do we have any other terms with just an x that aren't underneath a radical? No, there are no other like terms for that. So we'll just bring that along at the end, plus 4x. All right, I know. We're not done yet. There's still a couple x's in there. But look at what we originally started with. This problem. How many square roots did it have initially? It had 2 of them, right? Now, how many square roots do we have? Just 1. Okay, are we getting closer then to our answer? Yeah, we got rid of 1 radical. Now we have to get rid of the second radical. Now, to get rid of one of those radicals, we started by isolating the root all by itself. So guess what we need to do now? Yeah, we'll see this square root right here. Let's pretend this is a brand new problem that I'm just giving you right now. Let's say this is example 6. I said, hey, solve this, this problem. You would want to get the square root all by itself on one side, just like any other problem. So let's cancel some stuff out. Can I get rid of this 7 from the right side? What should I do? Yeah, let's just subtract 7. And now I'm bringing in the left side of the equation into play, right? I'm combining terms on both sides at this point. So this becomes 4x minus 6. Oops, equals. Oh, man. Here we go. So 4x, 1 minus 7 is negative 6, equals 6 square root 4x minus 2 plus 4x. Is there anything else we can cancel out from the right side pretty easily? Yeah, how about that 4x? Let's just subtract that from both sides. I'm going to subtract this 4x so that it cancels out. Do it from both sides. Minus 4x over here. Oh, look at that. 4x minus 4x equals 0. They cancel out on both sides. That's awesome. That's making this problem even easier for us. So what are we left with? A negative 6 equals 6 times the square root of 4x minus 2. We're just slowly peeling things away from that right side until the square root is all by itself. One last thing. What's left on the right side that we need to cancel out? Yeah, how do I get rid of it? Let's just divide. Divide by 6. Divide by 6. Because 6 divided by 6 is 1, it cancels out. Over on the left side, what's that going to equal? A negative 1. Excellent. So negative 1 equals the square root of 4x minus 2. So finally, can I cancel out that square root? By doing what? Just squaring. Nice and easy. So I'm going to square this. I'm going to square that. Negative 1 squared is a positive 1. Over on the right side, the square and the square root cancel each other out. 4x minus 2. And I mean, from here, piece of cake, right? What do you mean? What's going on? What, did I make a mistake somewhere? What are you talking about? Tell me, Frank. -1? What do you mean? You're right. You're exactly right. Frank said, hey, wait a minute. You got a square root of something equaling a -1? Can that happen? No. Excellent catch. And I saw a couple of you were like looking at me like I'm crazy. You guys trying to trick you. I was trying to trick you. And so if we did keep solving this, like if we added 2, we'd get a 3 equals 4x. Oh, that's gross. So x equals 3/4. Can you imagine plugging in a 3/4 back into that original problem to try to solve it? And then you do plug it in, and guess what happens to your answer? It doesn't work even. Isn't that funny, everybody? This whole problem, all this work. I'm so sorry. I'm so sorry.
I'm glad they don't have to do it.
And the whole thing, everybody, it's a no solution. I'm glad that like I'm getting more smiles from you as opposed to like you throwing your pencils at me right now. Okay, I will tell you on your tests, you're absolutely going to have a question like this, okay? You need to know this process. It's going to come up next year in pre-calculus. And the only thing with next year in pre-calc, this side won't divide evenly. And so like when I square this, I'd have to square like both terms, which I'm allowed because it's a monomial and blah, blah, blah. But that's something for next year to figure out. But yeah, this one, all these steps I did are valid despite it being no solution. Okay, and that is how you have to solve it. And so this is the type of problem like this where you've got a single term, like a single root on one side, and you have 2 terms on the other side. Okay, and you can't just square each of those. You have to square the whole thing and put them side by side and distribute them out. Okay. I know that you don't want to because it takes more time, but that's how you solve these problems. And remember, those steps aren't that difficult. The hardest part of that was 3 times 3, realistically. And that's pretty simple. And it's a lesson for today. Pretty cool? Yeah. All right. So the rest of the time, I'm going to give you just to do some practice on Delta Math. All right, get a giant jump start on your homework. But before that, I do just want to bring up the calendar just to give you a preview of what to expect before winter break. Okay, just so you know what is coming up. So remember, everything is always posted on my P-Learning calendar. Just go to Algebra 2. Go to the calendar. And here's December. Let me make this a little bigger for you. So first off, 8th hour, the class we're in right now, you're actually going to be like 1 day ahead. First and second hour, who is going to be listening to this recording, the next days, that's what this calendar is showing to match up with them, all right? Because they don't have me there teaching them. So we just did solving radical equations. That's the last lesson in Unit 5. Next week, we're going to start our unit on quadratic equations. That's just something where you have an x squared. If you think about a quadratic, it was a parabola shape. Do you remember that in Algebra 1? That like curved, upset, that U-shaped graph is a parabola. Those are quadratics. You might remember the quadratic formula. Remember that? Negative b plus or minus the square root, b squared minus 4ac. And there's a song. Yeah, you know the song. Wow, he's still singing. So that's next week. We're going to start this Unit 5. We're not going to finish it, though, before winter break. But that last week, the 14th through the 18th, we are going to have another test on this stuff so that you can take those 2 weeks of winter break off and just coast. Sound good? All right. So remember, though, take a look. Oh, not the calendar. You as a student. If you're wondering what's going to be on that next test, I mean, now is the time to start preparing. I'm telling you all now what's going to be on this test coming up. It's posted here. We have 3 new learning targets. First off, the complex numbers. This is the stuff with like I. Remember that imaginary number I, and like I squared equals -1. Shouldn't be that tricky. All right. Solving radical equations, that's today's lesson. So that's what we're going to practice right now. And then just this first target, writing quadratic equations in this vertex form, which we're going to learn next week. All right, the old learning targets from the test that you took just before Thanksgiving, 4.2 and 4.3. So basic operations with radicals. The biggest issue I saw with these was specifically dividing by a radical. When you had like a square root of 2x in the denominator, a lot of students left those blank, completely had no clue what to do. So that's when you go back to your notes and you go to your Delta Math and you practice those again. And then 4.3 is the relationship between rational exponents and radicals. So that's also when you have those fraction exponents and you're rewriting it as a root like we did in one of those examples today. So make sure you're ready in your free time, you know, when you're having some fun at home and you're like, hey, let's just watch some Netflix or whatever. Instead, you could pull up some Delta Math for like half an hour and just run through some old problems. I mean, that sounds like a great way to spend your evening or your weekend instead. So much better, right? And you can binge on math over the weekend. What? Delta Math binge. All right. Anyways, that's it for today. Good luck, everyone. Oh, wait, let me show you, I guess, the Delta Math. I mean, I'm sure you can figure it out. It's pretty straightforward. I just have two different types of problems for you to work through in this 4.5, solving radical equations. All right, there's the level 1, which is very nice and simple, where you're just, get the radical by itself, and then you're going to square both sides. I think these actually are all square roots even, all right? But on your test, I'm going to be giving you like cubed roots and fourth roots and stuff like that. Just raise it to the appropriate power. Nice and easy. Then the level 3s, these are those tricky ones, right? When there's a radical on both sides. And so for this problem here, like I would square the right side to cancel it out. But over here on the left side, I can't just square each of these terms. I got to put that in parentheses and multiply it by itself. Root x minus 1 times another root x minus 1, and you got to distribute, okay? So these second ones will take more time. If these ones do not take you a lot of time, that probably means you're doing it wrong. Go back, look at the example, right? Look at the steps, see squaring both sides, and even shows you right here how you write it out. You take one parenthesis times that parenthesis a second time. All right, so that's the second set of problems. So you got 5 of each of these, and you can get a good start right now. And if you have any questions, just let me know. I'm going to do my best to help. Anyways, I'll talk to you later. Have an awesome day.